Hello wonderful person, this is Anton, and it's time for our 3i Atlas update right before the end of the year. Because just now, on December 19th, 2025, when I'm making this video, the comet has officially completed its closest approach to planet Earth, and quite a few telescopes were able to capture new images and reveal just a little bit more about this somewhat bizarre object. And here's actually a really cool compilation of 6 separate pictures from 6 separate observatories, showing us this comet in completely different light. And in case you were wondering, nope, still just a comet. Despite being green, this comet does not contain any green men. And so, as we reach the end of 2025, after just 6 months, this object has already provided a wealth of data, dramatically changing our understanding of what interstellar comets seem to be and how chemistry outside of the solar system seems to work. Oh, and by the way, right here, it was actually still pretty far from Earth. The distance here was about 270 million kilometers, or approximately double the distance of Earth to the Sun. But that was close enough for a lot of these telescopes to capture new data, with some of the most exciting images coming from the Gemini North Telescope. This was released only a few days ago, but here we have a kind of a comparison of the before and after image using exactly the same telescope. And well, in essence, it shows us a dramatic change in color. When this comet was first detected in July, it appeared to be a slightly reddish tint. And this is believed to be the result of something referred to as tholins, a variety of organic compounds that a lot of other objects contain as well, and basically the same compounds that make Pluto a little bit reddish as well. And so when a lot of these organic compounds get illuminated by cosmic rays or even ultraviolet light, they eventually form this reddish material. However, as the comet emerged from behind the Sun, which happened in late November, new images from the same telescope reveal that it's now just a little bit more green. Or essentially now it contains a definitive greenish glow, which implies a slightly different composition. And normally this is caused by diatomic carbon, so basically C2, carbon that binds to itself. And so as the sun's heat penetrates the comet, these molecules are released and then excited by solar radiation, emitting light at green wavelengths. But here it's important to understand that this is obviously not unusual at all. Pretty much most comets display the same light, except that here, compared to local comets, this behavior was dramatically delayed. Normally, most of the solar system comets form this green halo way sooner. And well, that of course suggests that the surface of this comet was probably just a little bit different. We've actually discussed the actual reasons for this in one of the previous videos, but in essence, on the surface, it seems to have this very thick crust that formed as a result of billions of years of exposure to outer space, and specifically to very powerful cosmic radiation that this comet was exposed to as it traveled across the Milky Way. And that implies that this particular interstellar comet reacted differently to heat compared to comets we're used to observing. So not super unusual, but a little bit unusual. Here's actually another really cool time-lapse that shows us 2 separate comets in the same image. Although in this case 3i Atlas is barely visible. This was taken by the researchers from the Southwest Research Institute. And then we have additional images from the X-ray telescope referred to as XMM Newton, the telescope you see right here. And this was actually one of the most scientifically significant observations this month, originally conducted on December 3rd, where the telescope watched this comet for 20 hours. And well, it detected this, an X-ray glow. And well, here this is actually the result of a lot of stuff coming from the comet interacting with the solar wind. Specifically, when the gas molecules stream away from the comet, they then collide with the solar wind, which are of course charged particles coming from the sun, which creates X-ray fluorescence. But what makes this X-ray observation just a little bit unusual is that in this case, these X-ray observations are uniquely sensitive to gases like molecular hydrogen and nitrogen, which are almost completely invisible to optical telescopes, like for example Hubble telescope. And so in essence what we're seeing is hydrogen and nitrogen. We're seeing hidden ingredients that would be otherwise completely invisible. And that of course is going to help scientists in the next few months to piece together what this comet essentially contains inside and what kind of elements and in what amounts it seems to contain. So if it wasn't for this X-ray telescope, we would probably never be able to see either hydrogen or nitrogen. Although here we do have additional pictures from Hubble as well, with this comet appearing just a little bit brighter and a little bit bigger compared to previous observations. This was from December 5th of 2025. Then we have something really exciting coming from this study by these 3 European researchers. And here the analysis suggests that this comet seems to behave like a typical trans-Neptunian object and is basically experiencing what we refer to as cryovolcanism. And so here by observing this comet, scientists believe that as it heated up, a lot of solid carbon dioxide, or dry ice, turned from ice to gas directly, and very likely inside the nucleus, which in essence made this comet do something like this. And this process may actually trigger the flow of a lot of oxidizing liquids inside the comet that then react with a lot of iron and nickel grains locked inside the comet. So essentially it kind of initiates a bunch of chemical reactions, which might explain additional observations from the last few months. And so here this internal corrosion creates a lot of energetic chemical reactions that eventually blast jets of gas and dust into outer space. And this may actually also produce what's known as the non-gravitational acceleration, essentially shifting the comet's orbit by just a little bit. But this is of course something we've seen many times in the solar system. As a matter of fact, we've even discussed one of the most recent discoveries from an extremely famous cryovolcano right here in the solar system. You can learn about this in one of the videos in the description. But so far this indicates that the chemistry of 3I Atlas is remarkably carbon-rich. It essentially seems to be spewing out a lot of methanol and hydrogen cyanide at much higher rates than any other comet in the solar system. And methanol is actually particularly important because it's technically a building block for a lot of prebiotic chemistry that we believe existed on early Earth. And so at least when it comes to our own planet, this kind of stuff was crucial for starting life. And so seeing these ingredients in a visitor from a different star system definitively tells us that fundamental ingredients for life seem to be quite widespread in the entire galaxy. And then, as I mentioned in one of the previous videos, we have some additional pictures from missions in space that were actually on the way to a completely different planet when scientists decided to use their cameras to take a look at the comet from a different perspective. And so here we have our first picture from the mission known as JUICE, Jupiter Icy Moons Explorer. And so because it was so close to the comet, it was able to capture the view showing us an active coma, plus hints of both the plasma tail and a much fainter dust tail. Something that's typical for comets, but something that was difficult to see before. In this case, the plasma tail is just a bunch of ionized gas, and usually points away from the sun, and the dust tail is formed by ice particles, and usually moves in a different direction. This is basically material released by the sun as the comet heats up. Both of these tails are actually very different, because the plasma tail is made out of ionized gas, and the dust tail is made out of solid particles. But the separate mission known as the Europa Clipper that you see right here observed the comet from the opposite direction, and it produced this image. And so here, by using ultraviolet observations, scientists observed the comet's nucleus, its coma, and dust tail from a unique sunward perspective, in the process detecting oxygen and hydrogen, despite the comet being covered in a lot of gas. So this is essentially what you're seeing in this image. Now the details about this are going to come out sometimes in February or March, but for now at least we get one image. And then this particular study that was just released a few weeks ago was even able to determine the approximate mass of the comet by essentially observing by how much it seems to accelerate due to the emissions of all of this gas. And so here the rough mass estimate suggests that it's approximately 44 million tons, or at least it used to be this heavy back in August of 2025, suggesting that this comet is predominantly made out of CO2, and the total size of the nucleus is actually relatively small, just over 700 meters in diameter, or approximately 2,300 feet. And this is definitely much smaller than scientists previously assumed, because it was believed to be much larger, up to about 5 kilometers, with the scientists behind this study discovering something else. In essence here, by observing the tail of the comet, Sarah Rickard and colleagues from the study detected a faint high-latitude jet where they were able to track its wobbling motion, and this allowed them to then derive how fast this object seems to be spinning. Or basically they were able to see the rotation period of the nucleus itself, and it seems to be approximately 15.5 hours, which was the first time this periodic jet angle modulation was done in an interstellar comet, and allowed scientists to determine spin axes without direct nucleus observation. But this also suggests that a lot of this outgassing early on potentially changed the rotation of the comet, because it might have been a little bit longer before at over 16 hours. So essentially in this case, the comet seems to have spun up. And last but not least, there's one thing I never really got to mention in any of the previous videos. The person who found this, obviously completely by accident. He was actually this wonderful person, Dr. Larry Denneau, one of the members of the Atlas project, who captured the comet using Gemini North Telescope in Hawaii in July of 2025. And here's actually the first picture of the comet from July 1st. And so he discovered this by reviewing routine telescope data from Hawaii's Institute for Astronomy. and initially was thought to be an ordinary near-Earth object, something that scientists detect pretty much daily. But eventually, because of its hyperbolic orbit, that's when things got really exciting. And so within just 24 hours, this was confirmed to be the third interstellar object. And this highlights how incredibly powerful this ATLAS telescope is, because it's able to scan vast areas of night skies, capturing images of pretty much any moving object. And the reason this is important is, of course, in the name of the telescope. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its main purpose is to detect any potentially dangerous asteroid before it collides with our planet. So this is a very important planetary defense telescope. But the reason Larry Deneau in this case was important is because of his non-traditional background. With a degree in electrical engineering and computer science, he developed ATLAS software that can handle terabytes of data pretty much every single night and extremely accurately and reliably alert us of any potential danger. So technically this is one of those superheroes without a cape. I mean, most of us are not even aware this is happening, but here scientists are constantly observing the night skies to make sure that nothing is on a collision course, and to make sure that if something is on a collision course, we're prepared way in advance. As a matter of fact, his software was also responsible for the other exciting discovery from 2025, the asteroid YR4 that we discussed previously, that at first scientists thought may collide with the planet in 2032, but is now technically on a collision course with our partner, the Moon. You can learn about this in one of the videos in the description. And so that was, of course, the discovery of the comet and the person who confirmed its existence. And so I hope someone in Hawaii buys him a beer or something. I mean, this was a pretty remarkable discovery. But anyway, we'll definitely come back and discuss this object in some of the future videos, probably in the next few weeks, because after these December observations, we're going to have even more data and more analysis from several different teams. Until then, check out some of the previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.